welcome, dear students. In this lesson, we will study Chapter 5, Section 2, Chemical Bonds and their formation. First of all, let's know what is chemical bond. Highlight the definition for the chemical bond. Chemical bond is the electrical attraction between the nuclei and valence electrons of different atoms, which holds the atoms together. Until atoms together, this is the definition for the chemical bond. The main importance point in this definition is valence electron. What do you mean by valence electrons? Valence electrons means the electrons that locate from the outside of the outermost shell for each atom. For example, lithium has 3 electrons. The electron configuration for lithium is 1s2, 2s1. Let me show you the how can we determine the valence electrons. For example, here lithium. Lithium has 3 electrons. The electron configuration for lithium is 1s2, 2s1. Determine the highest energy level. Here it's 1s, here it's 2s. Because 2s is higher than 1s, so that take the highest one. Then, how many electrons are there from the highest energy level? We have 1 electron. So that valence electron for lithium is 1. Let's take another example. Carbon. Carbon has 6 electrons. Students, write down the electron configuration for carbon. It is 1s2, right? 2s2. Here, then 2p2. We said that the total number of electrons should be equal to the atomic number for the atom. 2 plus 2, 4 plus 2, 6. Here, we have 1s2, 2s2, 2p2 is the normal electron configuration for carbon. Then, take the highest energy level from this series. You have 1s, 2s, 2p. Take the highest number. Now, 2s and 2p. So that we have to choose 2s and 2p. Yes, 2s and 2p is the outermost or the highest energy level. And take the electrons from the highest energy level. In 2s, we have 2 electrons. In 2p, again, we have 2 electrons. So that carbon has 4 valence electrons. This is how can we determine the valence electrons. Clear? Okay. Let's turn back to the book. Okay, students. Okay. Students, write down a question. Why do atoms form bonds? Which means, what is the main reason behind bond formation? Atoms, the answer is, when atoms form bonds, their valence electrons are distributed in a way that increases what? Atom stability. So that the main reason behind bond formation is increase atom stability. So to increase the stability of atom. Clear? Oh, then depends on this electron distribution for the bond formation. There are 2 main types of, or let's explain the 2 main types of the bonds. We have ionic bond and covalent bond. In ionic bond, we studied that metal and non-metal bonded together to form ionic bond. Metal tends to lose electron, while non-metal tends to gain or accept electron. So as to what? So as to result in ionic bond. So that ionic bond made up from metal and non-metal. In contrast, in covalent bonds, there is a sharing electron, which means in covalent bond there is no any losing or gaining electron. Instead, both atoms share their electrons, and both atoms they own their electrons. or we can say the electrons are owned by both atoms. What do you mean owned by atoms? Which means there is no losing or gaining electrons. Yep. Oh, this symbol in some special textbooks called Lewis dot symbol. What do you mean by Lewis symbol? The definition for the Lewis symbol is a Lewis symbol for an element consists of the chemical symbol of the element accompanied by a dot. Dot means spot. نقطة يعني نقطة for each of its valence electrons. Students, for describing Lewis symbol or for writing Lewis symbol for each atom, we need two main things. The chemical symbol for an atom and the valence electron. For example, let me show you an example. For example, mhm. For example, carbon has 6 electrons, right? We said that the valence electron for carbon is equal to 4. Why? Because it has 2s, 2p. You have to take the highest number, highest energy level, had 2 and 2. We have 2s and we have 2p. How many electrons are there for the s? 2. And how many electrons for p is 2. So that valence electron for carbon is 2, our first. Then, to determine the Lewis symbol, write down the chemical symbol for carbon, as shown in your book. Show you. For example, carbon. Write down the chemical symbol for carbon. Then, surrounded by the valence electron, we determine that carbon has 4 valence electrons, so that 4 electrons are surrounded by the chemical symbol for carbon. Lithium, because lithium has only 1 valence electron, so the Lewis symbol for lithium is Li, 1 spot or 1 dot. Clear? Okay. Octet rule. What do you mean by octet? The octet comes from octa, which means 8. What do you mean by octet rule? We know that all noble gases except helium. What are the noble gases? Group 18 from the periodic table. Helium, neon, argon, krypton, xenon, radon. All of them except helium, He, have 8 valence electrons. What does it mean? It means that they have 8 electrons from the outermost shell, making them highly stable. It means that any atom that has 8 electrons from the outermost shell, this atom will be very stable. Then, what are the elements that they have 8 electrons from the valence or from the outermost shell? The noble gases except the helium. So that, what about the other elements? The other elements tends to have 8 electrons from the outermost shell. How? By what? By gaining, losing, or sharing. Please highlight these 3 statements. Gain, lose, or share electrons. For what? For the other elements rather than noble gases. Why the atoms? Why the other atoms doing that? So as to get stability, resembles to the noble gas. The other elements from the periodic table tends to gain, lose, or share their electrons so as to be resemble or like noble gases, and they will be very stable. This is the octet rule of types of chemical bonds. Dear students, in this textbook, we have 3 main uh, chemical bonds or types of chemical bonds. Covalent bond, ionic bonds, and metallic bond. First, we have covalent bond. What is covalent bond? And what are the class of covalent bond? The general definition for the covalent bond is, this yellow highlight is the definition for the covalent bond. A covalent bond is created when electron pairs are shared between 2 atoms. That's it. This is the general definition for the covalent bond. And depends on the pair of electrons. Depends on what? Of the pair electrons sharing between two atoms. There are three main classes of covalent bond. We have single bond, double bond, and triple bond. Single bond, it comes from its name, can be represented by a single line. Uh, it is a covalent bond. This is the definition for the single bond, in which only one pair of electrons, one pair, each pair is two electrons, so that we have two electrons, or one pair of electrons is shared between two atoms. Okay. This bond represented by what? This bond can be represented by either pair of dots or a short line between two atoms. For example, here, carbon-carbon single bond, or we can say a pair of electrons, two electrons. Hydrogen-hydrogen, a single bond, or we can represent by two dots. It is a single bond. First class of the covalent bond. Second class, double bond. A covalent bond in which two pairs of electrons are shared between two atoms. This type of bond is stronger than single bond, yes, because we have four electrons, two lines in the atom. Okay. The double bond can be represented by either two pairs of dots side by side, or what? Or two parallel lines. Yeah. Okay. For example, C2H4. We can represent the double bond by two parallel lines, or by four dots. Why? Because each bond can be formed between two electrons. This bond, two electrons. This bond, again, two electrons, so that we have four. Again, oxygen O2, double bond. Because we have double bond, again, we have four electrons. Triple bond, the last class for the covalent bond is, again, it's a type of covalent bond in which three pairs of electrons are shared between two atoms. This type of bond is represented by either three pairs of dots side by side, or three parallel lines. For example, carbon C2H2, a stealing gas. This is a stealing gas. Carbon with carbon can be represented by three lines, the triple bond. And each line consists of two electrons, so that we have six electrons. Nitrogen N2, because we have a triple bond, so that we can represent by three pairs of electrons, so that we have six electrons between these two nitrogen atoms. Thank you, and this is the end for this lesson.